One of the things that we mentioned when we talked about interfaces in the previous video was that they are used for defining a packageable behavior for some object. Okay, so let's consider this example. We want to be able to order instances of some class, and let's just say that we have some class called employee. Okay, and in this class, employees have a name and they have a salary. Okay, so let's say that we have a list of employees. Let's call it LS. And let's say that LS has a bunch of employees in it, a bunch of employee instances. Okay, and then we want to do something like list of employee sorted LS. And we will sort this list using the sort method provided by the Stream API. Okay, so how exactly will this work? Well, if we think about this, like let's suppose that this were an array, or sorry, a list of integers. Well, sorted would use the natural ordering of integers, which is from least to greatest. But the problem is that, and let's do another example. With strings, the natural order is with lexicographical comparison, okay? So from using the ASCII values. But with employees, there is no natural order, right? There can't be a natural order because there hasn't been a defined natural ordering. Like, how can we order one employee with respect to another? Okay? This is where an interface called comparable comes into play. The comparable interface is a generic interface over some type T that provides one method. It provides the public int compare to method, and it receives an instance of T, and what we return is the ordering of this object with respect to T. Okay, so it returns the ordering of this object with respect to T. So what do I mean by that? Well, we first should implement the comparable interface. So we'll say that this class employee, and just so you know, it's a very straightforward class. It just has two non-final instance variables, a simple constructor, and then two getters, two setters. Okay, so implements comparable over some type employee. So the type that we specify as the class name should always be the same type that we pass to the generic type here, because otherwise it wouldn't really make any sense, right? So what does this mean? This means that employee now behaves as if it were comparable. But what this means is that we have to implement the compare to method. Okay, we have to implement the compare to method, and I'll just move it right here. So we get this compare to method, public int compare to, and just like with so this is actually a point that I mentioned in the last video, but all interface methods must be defined as public. You cannot define them any way else. So just like with toString dot equals and hash code dot toString dot equals dot hash code, you have to put public as the access modifier. Okay, so do not omit that. The return type is an int, and it compares this employee with respect to another employee. And I realized now this should be employee. That's because I changed my example about 5 seconds before I made the video. Okay, so now, so how exactly will this work? Well, let's create an employee, E1. We'll make a new employee. Let's say Jack, and we'll say he makes $160,000, I guess. I don't know. It doesn't really matter. Employee E2 equals new employee. Let's say Owen, he makes $210,000. Okay. Now, how are we going to order these two objects? Like, for example, if I were to say E1.compare to E2, what type of value would this return? Well, consider what would happen if these were strings. Well, this would return a negative number if E1 comes before E2. It would return a positive number if E1 comes after E2. And it would return 0 if the two objects are equal according to some comparison metric. Okay? But what is that comparison metric? And the answer is, well, we don't know. I mean, that's a user definable metric, right? You can define this. This is what makes interfaces so nice. You can define any mechanism that you want for comparing employee objects. Okay? You can do whatever you want. It doesn't matter. You can compare them based on the name. You can compare them based on the salary. It doesn't matter. That's what's so nice about this comparable interface, right? We define how we compare employee objects. No one else does, okay? So let's say that we want to compare them based on salaries, okay? So what that would mean is that we're going to say that an employee, let's just make it formal, I guess. E1 comes before, I'll just use like this, I'll use this notation for, to mean comes before. Let's try and get it right. E1, an employee E1 comes before E2 if we order them, if E1.salary is less than E2.salary. Okay? So, and E1 comes after E2 if E1.salary is greater than E2.salary. Okay? But then what happens if they have the same salaries? Well, we can say E1, the position of it doesn't really, the position will be affected by, I don't have a symbol for that, the position of E1 is affected by E2 if E1.salary is equal to E2.salary, then the position of E1 is affected by, well, how do I want to phrase this? The position of E1, or the ordering of E1 with respect to E2, is defined, we'll say that it's defined by the lexicographical comparison of their names. So, for example, if we have two employees, let's make some more employees. We'll say Gilmore and Joshua. I don't know. Let's reverse these just for the heck of it. Let's say that we both make $413,000. We'll say E4, E3. That's not how much I actually make, by the way. If we want to do E3.compare to E4, then obviously it's like, well, how do we order E3 with respect to E4 and vice versa? Or similarly, how do we order E4 with respect to E3? Well, the salaries are the same. This is the comparison metric we're going to make. So we'll say that if the salaries are the same, then the comparison will be based off of their name. Okay, the comparison will be based off the name. So this means that E3.compare to E4, this should return a positive number because J comes after G. Okay, and correspondingly, this should return -1 because E4.compare to E3 should return a comparison that says G is less than J, or rather, G comes before J when we're talking about the ordering of characters. Okay? So, let's write that comparison. So, we're going to say if this.salary is less than O.salary, and remember that we don't need to use a getter here because we're still inside of the employee class. We don't have to go through a getter, which is kind of nice. So, if this.salary is less than O.salary, then we want to return a negative number that corresponds to, to signify or designate that this employee comes before O. So we'll just return -1. Okay? So what if this.salary is greater than O.salary? Then we'll just return 1. We'll say that this object comes after E1. Okay? And otherwise, we know that they're the same, so we'll just say return this dot name dot compare to o dot name. Okay, so that's good. So if we flip these, they should be the opposite of each other. So here, Jack makes less than Owen, so this will return -1. And here, of course, this is just the reverse. So let's see. Owen makes more than Jack, so we return 1. And we'll just say, let's just have 2 more employees that make the same. So we'll just say that, there's another employee with the same name and same salary as Gilmore. So we'll just say E5 dot compare to E4. Of course, this should return 0. Okay, and the same thing if we do E4 dot compare to E5. Okay, so it should be -1, 1, 1. Okay, this is going to run the wrong file. We don't have any JUnit tests. So let's see. Yes. Okay, so this makes sense. So we're returning the value of compare to. And remember that with strings, the compare to method will actually return the difference of the the difference in the character. So we see that G is 3 characters away from J, so that's why it returns -3 and 3. But the important thing is that it returns a positive number and a negative number for this example and this example, respectively. Okay, so this is how we say how to compare employee references. And now, if we wanted to, do the example that we had before with sorting, we could have a whole list of employees or a whole list of any object that implements comparable, and then it would be able to sort them. Additionally, this also means that we can put these objects inside of a tree set or a tree map. And the reason why is because now we know what it means to have a natural ordering. Remember, we've been saying the natural ordering of an element or a type? The natural ordering isn't anything special at all. It just means that the class or whatever type you're using implements the comparable interface. That's all it means, okay? So, natural ordering is it just means that the class implements comparable in one way or another. Okay, so all those times we've said natural ordering for strings or for numbers or for whatever, all those classes implement the comparable interface, and that's how we know how to order them, or how data structures like tree sets and tree maps and sorting algorithms know how to order a type of object.